In the last video, we went from uh, finding the simplest formula, the empirical formula, and this is really the part two where we're going to take the simplest formula and convert that into the molecular formula. So it's important that we can recognize the difference between the empirical and the molecular formula, and then that we're able to actually write out the molecular formula from that empirical formula. So real quick, if we look at the difference between empirical and molecular, if I have a substance like hydrogen peroxide, and this is the actual molecular formula, if I'm going to write the empirical formula of this one, it's the simplest form. So what we're going to do is reduce this by, it looks like the common denominator is 2, so we're going to reduce it by 2. So the empirical formula would just be HO. That would be the empirical formula. Okay? So here we go. The simplest formula of acetic acid is CH2O. The molecular mass of acetic acid is known to be 60 grams. What is the molecular formula? So the first thing we want to do is take the mass of this empirical formula that we have. We have the mass of the molecular formula. So what we do is put the molecular formula mass on top, which would be 60. That's 60 grams. And we need to find out what the simplest formula mass is. So I'm doing this real quickly. You would just add up 12. There's only one carbon. There's 2 hydrogens, so 12 plus 2, and then 1 oxygen is 16. And so the overall mass would be 30 grams. You take the total molecular formula divided by the simplest formula, and you get 2. And so what we're going to do now is just multiply the simplest formula by the number 2. So if this is our simplest formula here, 2 times CH2O. So the actual molecular formula of acetic acid is C2H4O2. And that's it. The more complicated problem I may give you is I may give you the percents. So what we're going to go back to is that empirical formula, and we're going to convert the percent composition into moles. And so that's what we're going to do here. So remember the molar mass of our really big ribose here. Hopefully you remember what ribose, it's a sugar in DNA and RNA, is 150 grams. So the molecular mass of ribose is 150. The chemical composition is 40% carbon, 6.67 hydrogen, and 53.3% oxygen. So remember, when we change percent to grams, all we're really saying is that we're going to use a 100-gram sample. And so when we do that, we just simply change the units from percent to grams. And I'm going to change grams into moles. So I'm going to divide all these by the molar mass. So divide this one by 12 grams of carbon. Grams cancel, so 40 divided by 12 is 3.33 moles of carbon. So again, what we're doing is we're finding the empirical formula so that we can, again, take its molar mass. So 6.67 grams of hydrogen divided by its molar mass, which is 1. I'll rewrite that one. 1.01 grams of hydrogen in 1 mole. 6.67 divided by 1 is 6.67 moles of H. And then finally, we're going to divide by 16 grams of oxygen per 1 mole. Grams cancel. So 53.3 divided by 16 equals 3.33 moles of oxygen. So this is what makes up our empirical formula, and what we're going to do next is take those numbers that we have and divide by the smallest. So the smallest one we have is, we can just use oxygen or carbon, it doesn't really matter. We'll just pick one because they're both the same. So I'm just going to pick, I'll just pick oxygen. So I'm going to divide hydrogen, and I always like to write what the numbers mean, so I write the symbol next to it. If I divide those two, I get 2. The next one I'm going to get 3.33 carbon divided by 3.33 oxygen, and I get 1. And I do the same thing with oxygen, and you know which should be oxygen divided by oxygen should equal 1. And now I multiply into a whole. So I don't have to do this for this problem so much, but I'm going to write the simplest formula because there's no like half numbers here. So I can just take what I have here, but if I did have like 2.5, then I would multiply everything by 2 so I could have an even numbers because I can't have a half of an atom. So write the simplest formula here would be C, carbon, there's only one carbon, H2, and then one oxygen. And I put it this order because in my problem back here, they're listed in that order: carbon, hydrogen, oxygen as well. So always write it in the list in the order that you're given. And so now I just find the molar mass of CH2O. I did this pretty quickly here. Carbon is 12, hydrogen is 1 times 2. Yeah, so there we go. Oxygen is 16, so I add that all up together, and I should get 30 grams of CH2O, which is the empirical formula. And so now I take my big molar mass of my molecular formula and divide it by my simplest, by 30. So I go back to the problem. It gave me 150 grams was the molar mass of ribose. 150. And then divided by 30 grams. 30 goes into 150, or 3 goes into 15 5 times. So this is what I'm going to multiply my empirical formula by. Let's see, I think it's on the next step. Actually, I'll just do it right here. So multiply empirical formula by the number calculated in 6b. So 5 times CH2O. So I get C5. Oh, C5 H10O5. And so this is the molecular formula for ribose. That's what we've just found, is the molecular formula right there. I think I'm going to write it. Oh, well. So that's there we go. I might write twice here. Molecular. Oh, yeah. I'm a little slow on me today. So this is the molecular formula of ribose. Oh, it's a B. Hardly a B. Okay. A couple little things, just a couple tips. Some steps that may be helpful is percent to mass, mass to mole, divide by small, multiply to whole. And that's just a nice little jingle, and really what you're finding is the empirical mass, and then you multiply the empirical mass by the difference between the molecular and empirical. So this is a nice way of getting the empirical formula, a nice way to remember it. Thanks for watching. Hope this helps.